All right, so I just posted 1 through 4 on the first page. So your graph should look like this. And now we're going to do 4B, and 4B has nothing to do with this first one. We'll call this one 4A. Has nothing to do. 4B, 4C, 4D, and 4E are all separate. So basically on your non-calculator portion of the test, 4B, 4C, 4D, or 4E could be a problem like that on your non-calculator, as well as number 17 on this review. That could be what stuff that's on your non-calculator. Anything else you'll have a calculator for. So we're going to do 4B right now for the second video here. And it wants us to graph a piecewise function. So I gave you some graph paper on the back. So we're going to make our own graph for 4B. So I know this is kind of dark graph paper, but it's the best I can do. So 4B, I'm going to make some graph. Just make a graph here. It's going to be kind of hard to tell unless you make it dark. So this is my y-axis. X-axis, we'll call it X, Y. So we have a graph, okay? So on the paper, I'm going to do it on the work over here. So the very first piece is basically y equals 2. That's what that's saying, y equals 2. So y equals 2 is a horizontal line that goes through 2 right here. So you look at your graph, it would go all the way across. But I'm not doing all the way across. I'm just doing the piece that is less than or equal to -5. So if you were doing a t-table, you would put a 2 here. And they're all 2's. But you only want the x that's less than or equal to -5. So -5, but I'm going to write closed circle because it's equal. And some numbers less than -5 are -6 and -7. So on my graph, I need -5. I'm going to do this in red. 1, 2, 3. Oh, I need to make this longer. So -5. 1, 2, 3, 4, 5, and 2 is like right here. And then -6, -5, and it goes this way. So that's your first piece. I almost didn't give myself enough room here. That's your first line. Okay, now the second piece of your line, again, draw a little t-table. The second piece is x plus 4. That means it's a line that has a y-intercept of 4 and a slope of 1. But its domain goes from -5 to 4. So I'm not going to use all the numbers between -5 and 4. I'm just going to go, I know I'm going to end at 4, start at -5. And maybe some numbers in between, maybe like -1 and 0 and 1 or something like that. You don't need all of them. So -5 plus 4 is -1. This is open circle because it says just greater than -5. -1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. Now 4 plus 4 is 8. That's the last one. And that's going to be a closed circle, 4 and 8. Because it says less than or equal to 4. So the 4/8 is going to be closed. The -1 is open, and everything in between is closed. Everything in the middle is closed. So the very first point is -5/1. I need, because this is such dark graph paper, I kind of need to do this in red because you can see it. -5, -1 would be 1, 2, 3, 4, 5, -1, and that's open circle. Okay, that's your first point. Your next point was like -1, 3, 0, 4. There's that y-intercept. 1, 5, and the last one was 4, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. It's about right here and it's closed. Make sure it's a closed circle. And I'm just going to connect that. So that is a line that has a y-intercept of 4, a slope of 1. I mean, there's points here, here. All these points you can fill in, but I don't need to do the t-table points for that. So that's a line that has a y-intercept of 4 and a slope of 1. Notice it's still passing the vertical line test because it's supposed to be a piecewise function, supposed to pass the vertical line test. So I assume the next piece is going to be somewhere over here so that it passes the vertical line test. So let's see. The last piece is negative 1/2 x, and it says x is greater than 4. So you have 4, 5, 6, 7, 8, and you can keep going. Greater than 4, this is going to be open. Negative 1/2 times 4 is negative 2. I'm not even going to plug in the 5 because that's odd. I'm going to plug in the 6. Negative 1/2 times 6 is negative 3. And negative 1/2 times 8 is negative 4. I'm going to skip the odds and just go do the evens. So it's very important to know that the very first point is open because it says greater than 4. So 4, negative 2. 1, 2, 3, 4. Negative 2. And that's open. It's a good thing it's open because if you do a vertical line here, this one's here, but this one is not. So it passes the vertical line test. The next point was 6, negative 3. So it's like right here. So it's going this way. So that's what your piecewise function for 4b looks like. 3 pieces of lines that pass the vertical line test. 4c. 4c says to graph this. First of all, you have to know that it's an absolute value. Absolute value means that it is a v. The negative outside tells you that's a reflection of v. Okay, it reflects over the x-axis. So it's upside down v. So where it would have looked like this, now it's going to look like that. Okay, so we know it's going to look like this now. Oops, when I put my hand there, it makes it blurry. Sorry about that. Let me focus that. So it's going to be an upside down V. The 1/2 out front means horizontal stretch by a factor of 2. So horizontal stretch by a factor of 2. This means it's 2 right, 2 units right. And the +1, good gosh, I think that was supposed to be on the outside. I think I made a mistake there. It just means you're going to go, because it's inside the bars, it means you're going to go, okay, I know that this is not supposed to be there. Only people that watch the video will know this. This +1 is supposed to be on the outside. The +1 is supposed to be on the outside. That's up 1. I put it in the wrong spot. That's my fault. All right, so we got to do all this. Okay, so let's get our graph ready. I'm going to show you this with a pencil. And I'm going to keep erasing every time I do a reflection. Instead of doing a t-table, I'm going to do it with a pencil. So the first thing I'm going to see is that this is an absolute value. The original points for an absolute value, let me get this graph here. Original points on absolute value is 0, 0, over 1, up 1, because the absolute value of 1 is 1, and the absolute value of 2 is 2. Absolute value negative 1 is 1, absolute value negative 2 is 2. This is what a parent graph of an absolute value looks like. Okay, you guys understand that? Can you guys see that? The pencil. So the first thing is, I like to do reflections first. I just think they're easier. So I would like do this, 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 and this. And then I would erase this. You guys okay with that? So this is where we're at right now. We're in an upside down V. Now, so that's this. Now I'm going to horizontally stretch it by a factor of 2. Stretch it. So do you see how this one right here horizontally is only 1 over? It's like over 1, down 1. God, you can't see what I'm doing. Do you see how this first point is over 1, down 1? If I stretch this horizontally by a factor of 2, I'm going to go over 2, down 1. So my next point, instead of here, would be I'm stretching it horizontally. So instead of over 1, I'm going to go over 2, down 1. So this point's no longer going to be here. Do you see how this point right here was over 2, down 2? Now I'm going to go over 4, down 2. So this is my new right side. You're horizontally stretching it by a factor of 2. So we are widening, we're making it wider by a factor of 2. If you want me to show that with t-table points, here's what we're at. In an absolute value, you have negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. So the first thing I did was I reflected it over the x-axis, which changed all of my y's. X's stayed the same. Reflect over the x-axis. Change y's. The next thing I'm going to do is I'm going to stretch by a factor of 2 horizontally. That means all of these are going to be doubled. So negative 4, negative 2, 0, 2, and 4. But I'm going to keep the y's the same. So this is where I'm at right now. That's where I am at right here on these. Right here. Negative 4, negative 2, all that stuff. This is where I'm at. So now I'm on 2 units right and 1 unit up. I usually do these together, 2 units right and 1 up. So if I would take these points right here, if I was doing 2 units right, 2 units right, I would add 2 here, and 1 unit up, I would add 1 to these. So I'm going to add 2 to all of these. That'd make that negative 2, 0, 2, 4, 6. And then I'm going to add 1 to all of these. Negative 1, 0, 1. Amen. Did I mess that up? No, 0 and negative 1. So this should be your final answer. So negative 2, negative 1. So basically we're taking this thing right here and we are going 2 units right. I'm going to do it with my black pen. 2 units right from this point and 1 unit up. That's my new vertex. This one, 2 units right, 1 unit up. 2 units right, 1 unit up. So there is this. This one, 2 units right, 1 unit up. 2 units right, 1 unit up. That should be my final answer. I'm going to get rid of my pencils. And these points should be the points of the last t-table. Negative 2, negative 1. Right there. This one, 0, 0. Right there. 2, 1. The vertex. And on and on. Okay, you can check it on the calculator. I did it by just graphing, erasing pencils, and I also did it by t-tables. Whichever is easiest for you. So now 4D is y equals 2 square root of negative x plus 1 plus 3. So in words, this is a vertical stretch by a factor of 2. The negative's on the inside, so that is a reflection over the y-axis. This 1 is left 1, and this 3 on the outside is up 3. I am going to, I always do my reflections first, so I'm doing my reflection over the y-axis first. So when I say that, you have to know that it's a square root. Okay, so if I was just doing a square root picture, let me draw a graph here. Okay, here's a graph. If I was just doing a square root, it would be 0, 0, the square root of 1 is 1, and the square root of 4 is 2. This is the parent graph. So your graph is going to look something like this. What does that look like in a t-table? 4D. X, square root of x, is 0, 0, 1, 1, and 4, 2. This is your main point. So the first thing that I'm going to do is a reflection over the y-axis, which changes the x. A reflection over the y-axis. Make sure that you change all of these x's right here to their opposite. Y's stay the same. So what does that look like? So the very first thing, reflection over the y-axis means that this is now here, and 1, 2, 3, 4, and this is here. So I'm getting rid of my original parent graph because it's no longer there, and now that's what a reflection over the y-axis looks like. Okay, now I think it's up to you which one you want to do next. We could go left 1 and up 3 first. We could do it one at a time. Let's just go left 1. We'll do that. Let's just do left 1. Let's go left 1 because it's like inside. Since we did this one first and we're plugging X, let's go left 1 first. So if you moved all of these left 1, it would be here, here, and here. Okay, so now we're here. We reflected over the y-axis, and then we moved it left 1. Let's do the vertical stretch by 2 now. Vertical stretch means, see how this is 1 apart from the x-axis? Now it's going to be a 2 away from the x-axis. And you see where this one's 2 away from the x-axis? A vertical stretch means it's going to be 4 away from the x-axis. But this one's at 0, it still stays at 0. So it's going to look like this now. Oops. So this is where we're at right now. What would that look like back here? So I never did the left 1 yet. We did left 1. That changes the x-axis. So left 1 means 0 minus 1 is negative 1. So you're going to subtract 1. Negative 2 and negative 5. But the y stayed the same. And then we just stretched it vertically by 2. That's the changing the y. Stretching it vertically by 2, so that means the x's stay the same. Negative 1, negative 2, negative 5, but we're going to stretch these by a vertical thing of 2. That means just multiply everything by 2. So that's 0, 2, and 4. So this is where we should be right now. Negative 1, 0, right there. Second point should be negative 2, 2, which is left 2, up 2. And the third point should be negative 5, 4, which is left 5, up 4. This is where we're at right now. We have one last thing, which is to add 3. So if I just add 3 to the y, my final thing is, from here, you're going to go up 3. Basically, adding 3 at the end means shift everything up 3. So your final answer is this. Make sure this is a point, and that's what your graph would look like. And I would erase this, because this is no longer there. And the red is your answer. What would it look like on a t-table if we add 3? Adding 3 would be adding 3 to all these, 5 and 7, but keeping the x's the same. So these should be the 3 ordered pairs that I'm looking for at the end. Negative 1, 3, right there. Negative 2, 5, which is right here. And negative 5, 7, which is right there. These are hard problems because there's so many reflections. So if you need to keep it organized with t-tables, you should do that because you don't want to mess up. 4E. Okay, so this is a log problem. I think this used to be on my old test, but I think I took it off. It's not that you shouldn't know how to do it, so I'm going to do it. So let's talk about this problem. F of x equals log base 3 of x. This problem is actually easier to do with an inverse. This is actually easier to do with an inverse. So I'm going to find the, even though I'm not doing it in the right order that I told you to do it in, I'm going to find the inverse right away. So first of all, this is what this problem looks like currently. Some people have trouble with logarithms, so they actually would rather graph its inverse first and then just switch ordered pairs. So this one is your current function. We're going to switch x and y because we're going to find the inverse. Okay, we're going to find the inverse. So we're going to switch x and y. Now, to put this and solve for y, we're going to swoop. So you start with the base 3. You swoop over here and pick up the x, and that equals y. So the inverse is 3 to the x. Now, how would you graph 3 to the x? For example, if you plugged in a 0, what's 3 to the 0? Hopefully you're saying 1. So one of your ordered pairs is 0, 1. If you plug in a 1, what's 3 to the first? 3. So that's 1, 3. And then if you plug in a 2, what's 3 squared? 9, 2, 9. That's the inverse. So what is the original function then? What's the reverse of this ordered pair? 1, 0. So now we're doing this. This is easier for some people. Instead of 1, 3, it's 3, 1. Instead of 2, 9, it's 9, 2. So basically, log base 3 of 1 is 0. Log base 3 of 3 is 1. And log base 3 of 9 is 2. Again, I'm not going to give you a test on this yet, but this is what is coming. It's what's coming. But if you could just do the inverse, most of you should know what an exponential function looks like. And then these are the ordered pairs for the logarithm. So now I should be able to graph this. Okay, so we're going to graph this one first. We're going to find the domain and range. Then we're going to graph this one, find its domain and range, and tell me if there's any restriction on the domain. All right, so we're graphing this one first. 1, 0, 3, 1, 9, 2. Here we go. So this is, what number is this? 4e. We are graphing currently f of x equals log base 3 of x. Okay, and we just did that right here. It's 1, 0, 3, 1, and 9, 2. You also have to know that logarithms have an asymptote right here, the x-axis. So you have 1, 0, 3, 1, and 9, 2. 3, 4, 5, 6, 7, 8, 9, 2. So your first function looks like this. That's what f of x is. I want you to write f of x right here. F of x. What is the domain of this? So since there's an asymptote right here, it's going to be all the x's greater than 0. So your domain is all the x's greater than 0. What's the best way of writing that? Your domain would be 0 to infinity. 0 to infinity. The range is actually negative infinity to infinity. It's all real numbers. Okay? So your range, so this is 0 to infinity. Your range is all real numbers. It's kind of hard to see on the graph here, so I apologize. So this is what your domain and range is currently. Is there a restriction on this? Does this pass the horizontal line test? Your answer to that is yes. This passes. That means there is no restriction. So no restrictions on the domain. So if I asked you to graph the inverse, it's going to be 0, 1 in the same graph. Here's 0, 1. This is right here is 3, 1. So you're going to do 1, 3. Wait a minute. Sorry, 1, 3 is over here. And this one's 9, 2. So you're going to do 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the graph of the inverse. So you would write f inverse of x. So you got the f of x and you have its inverse. So what would the domain of the red one be, of the inverse? The domain is all real numbers and the range is 0 to infinity. So basically it's the domain switched. So your domain for the inverse would be negative infinity to infinity and the range would be 0 to infinity. So that's the inverse. Domain and range. I did that kind of fast. I apologize. These are just add-on problems to make sure you're ready for the non-calculator. So you might have to rewatch that, but this is f of x. This is what your logarithm is. Punch it in your calculator. Just double check that. Although you can't use a calculator. And I'm not giving you guys a promise. I will not give you a logarithm tomorrow on the test. But this is coming, and you do have to know how to do logarithms eventually. But with logarithms, sometimes people like doing the inverse first and then flipping the order pairs. Makes it easier. Okay, the first page is now done. Should I stop this video so people can just see that first part? I think I will. I'm going to do this in chunks.